You have probably heard that the Milky Way is on a collision course with the Andromeda galaxy. You have probably heard it described as inevitable, catastrophic, the end of our galaxy as we know it. You have probably heard it is coming in about 4 billion years. A number so large it feels safe, theoretical, someone else's problem. Here is what you have not heard. In June 2025, a team of astronomers from Helsinki, Durham, and Toulouse published a study in Nature Astronomy that ran 100,000 simulations of the Milky Way's future, using the most precise data ever collected data from the Hubble Space Telescope and the Gaia star tracking mission, which has mapped the precise positions and velocities of nearly 2 billion stars in our galaxy. Their conclusion overturned decades of received wisdom. The collision is not inevitable. There is only a 50% chance it happens within the next 10 billion years. A coin flip. The fate of our galaxy, the home of every human who has ever lived, every planet we have ever found, every signal we have ever sent into the dark, comes down to a coin flip. And if the coin lands the wrong way, then we need to talk about what actually happens when two galaxies collide. Because it is not what you think. Before we talk about the collision, you need to understand what is coming. Andromeda, also known as Messier 31, is the nearest large galaxy to our own. It sits approximately 2.5 million light-years away. That distance is almost incomprehensible. Light travels at 300,000 kilometers per second. In 1 year, it covers approximately 9.5 trillion kilometers. 2.5 million of those years of travel separate us from Andromeda. And yet, Andromeda is the closest thing we have to a neighbor. In terms of size, Andromeda dwarfs the Milky Way. Where our galaxy contains somewhere between 100 billion and 400 billion stars, Andromeda contains approximately 1 trillion. It is more than twice as massive as our galaxy. Its disk stretches across approximately 220,000 light-years, more than twice the diameter of the Milky Way. If Andromeda were bright enough to see with the naked eye, which it barely is, as a faint smudge in the constellation of the same name, it would appear 6 times wider than the full moon in our night sky. It has been heading toward us at approximately 110 kilometers per second since the Big Bang. Not because of any specific event, not because of any catastrophe or explosion, simply because the gravity between the Milky Way and Andromeda is strong enough and the distance between them is close enough that they are falling toward each other, the way all things in the universe fall toward things more massive than themselves. They have been falling toward each other for approximately 13 billion years. And now, the question is whether they will hit. For most of the past century, the consensus was clear. The collision was coming, and it was essentially certain within 5 billion years. The reasoning was straightforward. Andromeda is approaching. Its velocity is measurable 110 kilometers per second, roughly straight toward us. The gravitational attraction between the two galaxies is calculable. The math seemed to point one direction, but the math was missing something. The Milky Way does not exist in isolation. It has satellite galaxies, smaller galaxies in orbit around it. And the largest of these, the Large Magellanic Cloud, is not small. The Large Magellanic Cloud is a dwarf galaxy approximately 1/10 the mass of the Milky Way, orbiting our galaxy at a distance of approximately 160,000 light-years. For decades, astronomers assumed it was a minor player too small to significantly affect the Milky Way's trajectory. They were wrong. The 2025 simulations from the Helsinki team incorporated the precise mass and velocity of the Large Magellanic Cloud for the first time, and its gravitational influence on the Milky Way is significant enough to change everything. In some simulations, the Large Magellanic Cloud's pull nudges the Milky Way's path just enough that Andromeda swings past a near miss rather than a direct hit. In others, the trajectories still converge. When all 100,000 simulations were averaged, the result was a 50% probability of collision within 10 billion years. 50%, not 90%, not certain, not inevitable. A coin flip, sitting in the sky 2.5 million light-years away, falling toward us at 110 kilometers per second, and we do not know whether it will hit. But here is the thing. Whether or not the Milky Way and Andromeda collide directly, there is one collision that is now considered almost certain. The Large Magellanic Cloud, our galaxy's largest satellite, is predicted to fall into the Milky Way itself within the next 2 billion years. 2 billion years before any Andromeda encounter. A preview of what a galactic merger actually looks like, arriving 2 billion years early. We are not waiting for the apocalypse. The smaller version of it is already scheduled. Now let us destroy the image in your head. When most people hear galactic collision, they picture something like a car crash at cosmic scale. Two objects slamming into each other, stars smashing, explosions, destruction. That is not what happens. And the reason it is not what happens is one of the most counterintuitive facts in all of astrophysics. Galaxies are almost entirely empty. The average distance between stars in the Milky Way is approximately 5 light-years. 5 years of travel at the speed of light to get from one star to the next nearest one. If you were to scale our solar system from the Sun to Pluto down to the size of a grain of sand, the nearest star would be about 4 kilometers away from that grain of sand. When two galaxies collide, their stars do not hit each other. They cannot. The space between them is too vast. In the entire duration of a galactic collision, billions of years of two galaxies passing through each other, separating and merging again, the probability of any individual star directly striking another star is extraordinarily small. The Milky Way contains at minimum 100 billion stars. The collision might cause a handful of direct stellar collisions, if that. What actually happens in a galactic collision is a gravitational reshuffling. Stars are flung into new orbits. Star-forming gas clouds are compressed and collide, triggering an explosion of new star formation, a starburst that can produce more new stars in a few 100 million years than either galaxy formed in all the billions of years before. The elegant spiral arms of both galaxies are torn apart by tidal forces and rearranged into something new. The end result, after the two galaxies have passed through each other multiple times and their combined gravity has finally settled, is not a spiral galaxy, not two spirals, an elliptical galaxy, a vast, roughly spherical cloud of stars with no arms, no disk, no clear rotation, just stars orbiting a common center in random, overlapping paths. Astronomers have already named this future galaxy. They call it Milkomeda. If the collision happens, if the coin lands on collision, here is how it actually plays out, step by step. Approximately 2 billion years from now, something visible begins to change. Andromeda, currently a faint smudge in the night sky, starts to grow noticeably brighter and larger. Naked eye observers, if any exist, can see it spanning multiple degrees across the sky. Approximately 3.75 billion years from now, Andromeda fills a significant portion of the night sky. Its spiral arms stretch from horizon to horizon. Not like a moon or a planet, like a glowing, banded river of light arcing across the entire visible sky. Billions of new stars visible as individual points in the approaching galaxy. Earth is not threatened at this point. The sun is still burning. But it is getting hotter slowly. Over billions of years, the sun's increasing luminosity is raising Earth's surface temperature. Life on Earth, as we know it today, will likely be gone long before the galactic collision happens. The surface of the Earth will be far too hot for liquid water approximately 2.8 billion years from now, before the first close approach of the galaxies. The collision itself happens in stages. First close passage, approximately 4 billion years from now. The two galaxies brush through each other. Their dark matter halos overlap and create gravitational drag. Tidal forces tear long streams of stars out of both galaxies. Tidal tails that stretch for hundreds of thousands of light years into intergalactic space. The galaxies separate, slow down, fall back toward each other. Second close passage. Approximately 5.1 billion years from now, the galaxies pass through each other again, more violently. More tidal disruption, more star formation triggered by compressed gas clouds. Final merger. Approximately 5.4 billion years from now, the two galaxies can no longer escape each other's gravity. They coalesce. The spiral structures disappear. Milkomeda is born, a single vast elliptical galaxy containing more than 1 trillion stars. And then, approximately 17 million years after the final merger, the two supermassive black holes at the centers of the Milky Way and Andromeda, which have been slowly spiraling toward each other through the heart of the new galaxy, finally collide. In the moments before they merge, they radiate gravitational waves with the power of 10 quintillion suns. A pulse of space-time distortion radiating outward from the center of Milkomeda at the speed of light. The loudest event in the local universe since the Big Bang. Now for the question you have actually been wondering about. What happens to us? Not to the galaxy in the abstract, not to stars in general. What happens to our specific solar system, our specific sun, our specific pale blue dot? The honest answer is, we do not know exactly. But we have probabilities. Harvard-Smithsonian simulations of the Milky Way-Andromeda merger calculate a 50% chance that our solar system will be flung outward away from the galactic center to approximately 3 times its current distance. Currently, we orbit about 26,660 light-years from the galactic center. In the merger, we might be pushed to roughly 80,000 light-years from the center of Milkomeda near the outer edge of the new galaxy. From that position, the night sky would look extraordinary. The entire vast structure of Milkomeda, more than 1 trillion stars, would be visible as a dense band of light stretching across the sky. The galaxy we are part of would be visible as a structure around us in a way it never is from our current position deep inside a spiral arm. There is also a 12% chance our solar system is ejected entirely, flung out of Milkomeda altogether into the void of intergalactic space. Intergalactic space, not between stars, between galaxies. A region of near absolute emptiness where the nearest galaxy might be millions of light years away in every direction. Our solar system, alone in the dark, with no galaxy to belong to. The night sky from that vantage point would be profoundly different. Fewer stars, the galaxies of the local group visible as distant smudges, a darkness deeper than anything we experience now. But, and this is the crucial point, our solar system itself would survive. The sun would still be there, the planets would still orbit. The emptiness of intergalactic space does not destroy stars. It just isolates them. And the remaining 38% probability, our solar system ends up somewhere in between, still within Milkomeda, but in a different position, a different orbit, circling the center of a galaxy that no longer looks like the one we were born in. None of these scenarios directly threatens the solar system. The collision is not our death. It is our displacement. Let us spend a moment with the most beautiful part of this story. Right now, our night sky is largely empty of galactic structure. The Milky Way is visible as a band of light across the sky, but we cannot see its spiral structure. We are inside it, unable to see the shape from within. The rest of the sky is mostly dark, with only a handful of other galaxies visible to the naked eye. As Andromeda approaches over the next 3 billion years, it grows in the sky. Not suddenly, not dramatically. A millimeter of angular size per century, invisibly slow by human timescales, but relentlessly, inevitably. 3.75 billion years from now, Anyone looking up from wherever the Earth is at that point would see Andromeda spanning 6 times the width of the full moon, a galaxy stretched across the sky. Its spiral arms visible as distinct structure, its core glowing with the light of billions of stars. As the first close passage begins, as the tidal forces start tearing streams of stars from both galaxies, the sky would begin to fill with light. Long arcs of stars, stripped from their original galaxies, trail across the darkness like rivers of light. New star formation blazes in the compressed gas clouds, brilliant blue-white supergiants forming and dying in millions of years. Their deaths lighting up regions of the sky with nebulae and supernova remnants. The sky during the collision, from wherever our solar system ends up, would be the most spectacular thing any consciousness has ever witnessed. An entire second galaxy, visible in all its structure, filling the sky and slowly, over hundreds of millions of years, merging with the first. No living thing will see it. The Earth will be long dead by then. But if something could see it, if some future intelligence, some kind of consciousness we cannot imagine, existed during this collision, they would be watching the greatest light show in the history of the local universe. Step back. A coin was flipped at the beginning of this story, and it is still in the air. The most precise measurements ever taken of our galaxy's future data from nearly 2 billion stars, run through 100,000 simulations, say we do not know whether the collision happens. 50%. And somehow that uncertainty is more unsettling than certainty would be. If the collision were certain, we could mentally prepare. We could accept it the way we accept the death of our sun, with the distant philosophical calm of someone confronting an inevitable but very far away truth. But 50% means it might not happen. It means there is a version of the future in which the Milky Way and Andromeda swing past each other close enough to distort each other, to pull out tidal streams of stars, to reshape each other's outer edges, and then separate, move apart, continue their individual existences for billions of years more. 2 galaxies that almost touched, that fell toward each other for 13 billion years and missed. And it also means there is a version of the future in which they do collide, in which the 2 largest spiral galaxies in the local group slowly, over billions of years, lose their beautiful structures and become something new. Something without arms, without a disk, without the elegant sweeping shape that makes spiral galaxies the most beautiful structures in the universe. Both futures are possible. The coin is still in the air. But here is what is not uncertain. Right now, tonight, Andromeda is out there. In the constellation Perseus, barely visible to the naked eye as a faint smudge of light, it sits 2.5 million light-years away, moving toward us at 110 kilometers per second. It has been falling toward us since before the Earth existed. Whether it hits or misses, it is coming. And looking up at that faint smudge, knowing that it contains 1 trillion stars, that it is the largest thing in our night sky, even though it looks like nothing, that it is both the most distant object visible to the naked eye and the most significant object in the future of our galaxy, is one of the strangest and most humbling things a human being can do. Go find it. While the coin is still in the air,